We will go over the warm-up shortly. We will start lesson 15 today. We will not be able to finish it because we do have to take the mid-unit 7 quiz, but we'll do that the second half of class. That way you have some time to kind of get warmed up. It's only 5 questions. Honestly, I could have given it to you at the start of the week, and I'm not worried about it at all. But I had been telling you that it would be Thursday, April 20th, but I'm not here, so now it's today. So regardless, you should be ready to have your notes for every lesson, even the ones that you were absent for, because not next week, but the week after, we are testing for unit 7. Probably arguably the hardest unit of the school year. And then, you know, that's mostly it. So make sure we're staying on top of our grades. All right. Again, I'm recording. It's always linked in the slides. Puzzle piece will be lesson 15. You may or may not know how to do it based on what we covered today. Just covering a little bit of it. Just want to remind you, so you'll notice in today's lesson, some parts might be a little tricky if you did not do what you were supposed to do yesterday. So I just want to remind you, even if you were absent too, you're still responsible for doing the assignments I leave for yourself. You don't necessarily need the papers I passed out. If you want them, you can ask me for them later, but there was notes to take and a practice to do. And if you followed instructions, and here's an example of the instructions in the slides that you could have looked at, it was just evens or odds on the practice. So if you did all of it, then you know you get extra practice. But both are uploaded to Schoology. I was not collecting any of that physically. So once those notes are taken and the practice is done, uploaded, they have separate links. So do take care of that if you haven't already. The reason I chose that lesson was because I think it's easy enough for you to learn on your own. And it's going to be really helpful for the quadratic formula, which I won't show you today because we won't have time to finish the lesson, but it's a part of it. So it's one of those like pre-algebra skills that they expect you to know, regardless of whether your teacher actually taught it to you or not. In my experience, I always have to reteach it. So simplifying radicals is just one of those things that you need to know how to do now and moving forward in your math. So feel free to watch those videos. It's 2 parts, but that's because last year we did it, like we did other lessons during that time, that same day. So it was just split into 2 parts. Okay, anyway, so yeah, that's yesterday's obligation. You still have it done. Now to the warm-up. So we have to find the area and side length of each square. So what's the formula for area of a square? What was that, Christina? Length times width. So same as a rectangle, but what's unique about squares?
Equal sides.
They have all the sides the same. So for a square specifically, you could also do side squared. Or length times width, because it happens that the length and width will be the same. So then who thinks they have the, let's do side length first. What's the side length of square A? 3 for the side length, so count 1, 2, 3 units, which makes the area 9. So however you did it, 3 times 3, 3 squared, they both give you 9. All right, that one's easy because it's lined up along the grid that you can just count it. Could you do that with square B? No. Did anyone get the side length for square B? Because we did do some stuff like this when we were practicing for Aspire. So I hope that you guys were able to figure out the side length. Anyone? Okay, Brian said, is it 1? Is it? Okay, you got 2. So let's see. It's not perfectly aligned like how A is, so we can't just assume. We would have to problem solve it. So what I would have done is make a right triangle using the grid that is, straight and to make a right angle. And then solve for my hypotenuse, which would be what side B is, the side length. So what's the base of my triangle? How many units? And then this side of my triangle is, and what's the formula for Pythagorean theorem? Okay, good. So a squared plus b squared equals c squared, where c is your hypotenuse, the longest side. So that's what we're solving for. So it's still going to be c squared. It doesn't really matter which one is a or b, just so you know. They both happen to be 1 in this one. What's 1 squared? Good, and then 1 squared again is also 1. The c is not alone, right? So what is the opposite of squaring something? Square rooting. And then first I should probably add the 1. What's 1 plus 1? All right, so we're going to square root to get the c fully by itself. And is 2 a perfect square? So then what's the square root of it? All right, I've not gotten a response. So here's how you can tell if something's a perfect square. And it was covered in the video yesterday too. You could find it on the little keypad, the square root symbol looks like that. Type in the number. And I know it's not a perfect square because it gives me this really long decimal. And when we're doing these problems, I don't want to round the decimal. So I'm going to leave it in what we call its radical form. Okay, so that symbol, that square root symbol, is really actually called a radical symbol. It's just when there's no little number right here. And I'll show you an example of when there is a number right here. So let me maybe put it in a different cell. Right, so when there's no little number right here, that number is what? Let's see who watched the video yesterday. Right, so no one knows. It's also, if you watch the video, if notes on that note sheet, it would have been like at the very top. If there's no little number written there, if there's no index, the index is what? 2. That's why when there's no number written there, it's a square root symbol. If there was like a little 3 written there, then it's a cube root and so forth. So yeah, square root of 2 is not a perfect square. You could try to see if you can simplify it, but nothing goes into 2 other than 2 and 1. So we just leave it as square root of 2. That is my side length. So if you round it and then multiply those to get your area, it's not going to be exact. So we want to leave it in its exact form. Questions on that? All right. And then area we said is length times width. So square root of 2 times square root of 2. Or you can write it as the square root of 2 squared, since it's a square. The side length squared. What's my area going to be for that one? Type it in Desmos and see, or you could just remember something that always happens when you square root a square. Wow, you guys might be calculating that. What if it was like the square root of 9 and then squared? What's my answer going to be? 9, right? Because square root of 9 is 3, and then you square it again, you get 9. They cancel each other out. So my area for B is going to be what? 2. Or you could put it in decimal and it'll still tell you that. Square root of 2, then square it. Good? Okay. So then C, now that I've taught you B, I hope you can figure out the side length and the area for C. So try that for about a minute. Now that I've shown you how to get there. So square C, what is the side length of square C? Ryan, what do you think? Square root of 10. Anyone get something else? All right, that is correct. I'll show you again. But then if my side length is the square root of 10, then what's my area? 10. The square root of 10 times square root of 10. You get 10. All right, but for square C now, again, it's not perfectly aligned like A was, so you have to do some more problem solving. What's my base of my triangle there? 3 units was inside. And the reason I'm doing that is to solve for my hypotenuse using Pythagorean theorem. So making a right triangle, you can do that. So then plugging it into Pythagorean theorem, I'll put 3 as my A, 1 as my B, C is my hypotenuse, so it has to say C. So what's 3 squared? What's 1 squared? Add those together, we get, and then opposite of squaring something is good. And you could have seen if you could simplify that radical, but if you follow those steps from the lesson yesterday, what goes into 10 other than 10 and 1? 5 and 2. There's no common numbers there, right? So it can't be simplified. It's just radical 10. And then, yeah, same thing, questions? All right. So then moving on, this lesson is called Quadratic Equations with Irrational Solutions. So whenever you have a non-perfect square, you have an irrational solution. So irrational numbers are like decimals that go on forever and never repeat. So like pi, for example, or non-perfect squares. So down here for this activity, we are going to solve each equation and use the plus or minus sign when appropriate. So looking at them, we can do one together. Which one do you think looks the most difficult? Okay, someone said 1. Like to differ. 6. 2. Okay, so raise your hand if you want to see 1.
Thanks, Stallion. Next week we have our senior.
So raise your hand if you want to see 1. Raise your hand if you want to see 2. For the example. Okay, so it'd be like 2, 3, 4. Raise your hand if you want to see 6. Okay, so there's more for 6. And looking at the answers, I do think 6 might be like the harder one. So I think that's a good choice. My first hour picked 1 and that happened to be like the easiest one. So number 6. In all of these, when it says solve, what am I asking you to figure out? The answer for what x is. So yeah, whatever value of x makes it true. We've learned how to solve these a few different ways. Since there happens to be just like 1 x in each problem, I think isolating the variable might be the easiest. So always start with what's farther from the x. That be that 2 or the 1? And that's a square, right? So opposite of squaring is, and whatever you do on one side. Okay, great. On the left side, I have just the x plus 1 alone. On the right, is 18 a perfect square? No. It is not. So that is what I showed you how to do yesterday, is to simplify it. You'll still want to simplify it. And the way that you do that, in case you didn't watch the lesson, is you make a factor tree, break it into its prime factors. What are 2 numbers that multiply to 18?
8, 6.
Okay, there's a few different ways, right? I just picked one of them. You just can't do 1 in that number. That's like only limitation. Are these both prime? So prime means it can't be broken down anymore other than 1 in itself. So which one is not prime? 9 is the only one that's not prime, because 2 is just 2 and 1. So that one's already. 9 breaks into 3 and 3. So now only look at the prime numbers. I'll even cross out the non-prime numbers because I don't want you to get confused. Only looking at the prime numbers, are there any pairs of the same number? Have a pair of 3s. So the analogy I used yesterday is that this radical symbol is like a little jail cell. Okay, pretend like it is. To escape the jail, you need a partner. So like the 3s can escape because they have a friend. For every pair, you write it once and it'll go outside the jail. Inside would be this leftover 2 that doesn't have a partner, so it doesn't escape. And that's the simplified version of radical 18. Yep. And also the whole point of this is we're wanting to use the plus or minus signs when appropriate. Anytime you square root something, you technically have 2 answers. So anytime you square root, you're going to have a plus or minus sign. And it's going to go in front of whatever the square root is. This time it's not perfect, so we're going to put it in front of this. Questions on that? All right, we're still not done because x is not alone. What's opposite of adding 1? Whatever you do on one side. And it is possible that your answer won't be like a number, essentially. It'll be like an expression like this. This is an example of that. So my answer for 6 is that x equals -1 plus or minus 3 radical 2. Okay, questions on that? All right, so try 1 through 5 with your tables. Just focus on the isolating x. Start with what's farther, then do your inverse operations and all that good stuff. I'll check in a few minutes. Okay, that probably wasn't enough time to do all of them, but I at least want to do some before we have to stop and take our quiz. So number 1, look at the x, think, what do I need to do to isolate it? What's farther, that 2 or the -13? And how do I make that 13 cancel? Added. And whatever you do on one side. Okay, good. So then I have on the left side x squared, that the 13's cancel. Oh. And then -12 plus 13 is a positive 1. X is still not alone, so now we get rid of that 2. The 2 is a square. What's opposite of squaring something? Whatever you do on one side. And the x is now alone. And anytime you square root something, you always have positive or negative. So get in the habit of having that plus or minus anytime you square root. What's the square root of 1? So plus or minus 1, yes. So that's why I said number 1 was probably the easiest. Because the other answers don't look as nice. Questions on that? So then let's look at number 2. What's confusing? Tell me. No, that. Oh, okay.
It's 2.
All right. So isolate the x. And then of course, there's other ways we've learned how to solve. But for right now, let's just, the whole point is to get used to the plus or minus sign. So isolate the x, what's farther, the 2 or the 6? And it's a square. So again, opposite of squaring something is 3. Whatever you do on one side. So x minus 6 on the left. Now, the whole point is we've been trying to get used to the plus or minus. But is there a plus or minus for the square root of 0? Because what is the square root of 0? 0. So yeah, there's not a positive 0 and a negative 0. So that's a situation where we wouldn't put it. And then x is still not alone. So instead of subtracting 6, we do that on both sides. 0 plus 6 is, and so in this situation, we just have one solution. Because square root of 0 is just 1, there's not 2 zeros. Okay, questions on that? Okay. Let's do number 3, and then we'll stop and take our quiz. So number 3, I have x squared plus 9 equals 0. Isolate the x. What's farther, the 9 or the 2? How do I cancel the 9? Whatever you do on one side. So then on the left, I have x squared. On the right, 0 minus 9 is, and x is still not alone. Opposite of squaring is, whatever you do on one side. Now, what's the square root of negative 9? Well, did you put that in your calculator? No. Right now. If you did, you would have seen that it is impossible to take the square root of a negative. All right, when I put that in my calculator, it says undefined because it's impossible. Because just like anytime you square something, you should never get a negative. You can't take the square root of a negative. So for number 3, there's actually no solution. So that's impossible to do. So for 3, there's no solution because you cannot square root a negative, right? It gives you an error method. In algebra 3-4, you'll deal with what's called imaginary numbers, and then you can answer that, but we're not there yet. So just for now, it's impossible. Questions? Okay, that's all we're gonna do today because we do need to pause and take our quiz. So just don't lose your notes ever. Keep all your notes somewhere safe.